So now I will show you basically the Laplace transformation of sine omega t. So which means that if t equal sine omega t, and so from the definition of the Laplace transformation, what we know, Laplace transformation of if t equal e to the power minus st if t dt, 0 to infinity, right? 0 to infinity. So now instead of ft we will write e to the power minus st, then sine omega t dt. I think there is no doubt here, right? And this is the chain rule. We'll solve this problem with the help of chain rule. So let's familiar with chain rule one more time. I know many of you already know it, but you know it's a bit complicated, so over the time you may forget it. So on the chain rule we need to define, so basically what is chain rule? Chain rule is 0 to infinity u dv equal u v, so 0 to infinity minus 0 to infinity v d b du. Okay, v d b du. This is the chain rule. So for this problem we let first define uv. So here we'll consider u equal sine omega t. So du equal omega cos omega t and multiply by dt, right? Because du over dt equal omega cos omega t and then multiply by dt, and dv equal e to the power minus st, and then from here by integration we can write v equal e to the power minus st and then divided by minus s. Okay, and now if we substitute this, I mean uv 0 to infinity, so basically what we will get from there? So we'll get u equal sine omega t, u v equal e to the power minus st over minus s, then 0 to infinity minus v equal e to the power minus st over minus s, du equal omega cos omega t dt. So 0 to infinity. And now look here, if we substitute infinity here, e to the power minus infinity is 0 and sine 0 is 0, so e to the power minus infinity, so first we will get 0 minus sine 0 is 0, so 0 minus 0. So this part is basically 0 minus omega over s, so minus plus omega over s, omega over s, so omega here is here, e to the power minus st cos omega t dt. Okay, e to the power minus st cos omega t dt. Right, so don't be confused. This was the part of this side. So we need to do the do the calculation one more time. So here basically here 0 to infinity, right? 0 to infinity. So here we'll start from there, 0 to infinity, then omega over s e to the power minus st cos omega t dt. This is the expression. Let me bring a couple of papers. Okay, I'm almost out of paper. So now we need to apply the chain rule again. So omega over s 0 to infinity e to the power minus st cos omega t dt. And now we need to define uv again. So u equal cos omega t du over dt equal minus sine omega t, then omega, right, du over dt. So du equal minus sine omega t, then multiply by omega dt, and then v equal dv equal e to the power minus st, v equal minus e to the power minus st over s. So this is the uv again. So uv is cos omega t multiply by minus e to the power minus st over s. uv minus integration 0 to infinity v du. V is minus e to the power minus st over s, and du is multiply by minus sine omega t omega dt. Okay, so uv, let me here 0 to infinity. So from here actually we can write here one thing actually I was type of missing. So the whole term multiply by omega over s. Okay, whole term multiply by omega over s. So look here, omega over s was here, right? Omega over s. So now here omega over s, and I'm substituting the limit. So e to the power minus infinity. So here e to the power minus infinity is 0. So the first term will be 0. So here first term will be 0, and then if I substitute 0, cos 0 is 1, e to the power minus 0 is also 0. So basically minus 1 over s. Okay, so this part is done. And then minus omega over s, then minus omega over s, then here 0 to infinity. So look here, here is minus, here is minus, so minus minus plus. So e to the power minus st over s, then multiply by sine omega t omega dt. So from here what we can write, omega over s square minus omega square over s square 0 to infinity e to the power minus st, and then sine omega t dt. So from here we can write omega over s square minus omega square over s square and e to the power minus st sine omega t dt 0 to infinity. So we can write Laplace transformation of sine omega t, right? Because this was the definition of Laplace transformation. So we started from the Laplace transformation sine omega t. We started from here and we got this is equal omega over s square minus omega square over s square, Laplace transformation of sine omega t. So if we simplify this, so then Laplace transformation of sine omega t, then here is 1 plus omega square over s square equal omega over s square. Laplace transformation of sine omega t is basically multiply by s square here, s square plus omega square equal omega over s square. So Laplace transformation of sine omega t equal omega over s square plus omega square. So this is basically the proof, or this is the answer. So we can write Laplace transformation of sine omega t is equal omega over s square plus omega square. Okay, so that's all for this session. Next session I will start new topics. Okay, so here on this also is given, right? Okay, all right, so thank you.